Okay, Ron, thank you. You already started talking about me. I'm web architect at LivePerson. I'm here for almost 7 years. Actually, there is a member of audience that brought me here. They still don't like him, probably for that, or because of that, but I'm grateful. Something personal about me, I used to like to sleep till 11. And I used to come to work at 11 and work till 9, 10 until I got kids. And this is me at around 8 a.m. or 7:30. I barely can see, but the kids are shouting, Abba, Abba. Actually, they are teaching me Hebrew, so my Hebrew is at their level. So if you want to hear me talking Hebrew well, you have to wait for them to grow up a bit. Today we're going to talk a little bit about the architecture overview and the transition LivePerson did in its architecture. That's me going to present. I'm going to leave some hooks in the presentation for two other people to present. They're two members of UI framework team in LivePerson, and they're going to present building happy web application while staying still sane and not angry. And the second one is Stay Out, Please, which is going to talk about cross-domain communications and how we solve this problem in LivePerson. So let me begin on my part, at least. Enterprise service, what does it mean? First of all, it has to be very, very scalable. You can add a customer in one day and it will triple your traffic. Not a lot of cases that happens in life, but one customer can triple your traffic. It has to be very secure. You can get penetration tests every day without you knowing. So on weird things, we had very funny discussions with our security team on why do the customers consider it a P1 bug or P0 security issue, but they do. There is no argument. There is a vector of attack, some very obscure ones, but you do need to handle it. It has to be stable. It has to be 4 nines and plus, and it has to be flexible. On one hand, you have security that tells you it has to be secure, production that tells you it has to be available, stable, monitored. On the other hand, you have product managers that tell you, yeah, we changed our mind yesterday, today develop another feature. They don't care that it changes some of your assumptions in architecture completely. They don't even understand the boxes or anything involved in the system. So we are kind of in the middle technologically, and we do need to be to raise those issues with flexibility. What we want to develop as client-side developers, really, it's single-page applications. This is the new craze. It's an amazing feature to have in your resume. It really opens up your possibilities. We want to build fast UIs. A lot of companies did a lot of research that if you delay the page load time by half a second, your conversions drop. So we want to have responsive UI. We want to have fast UI. We want to have very quick and fun UI for the user to do. And now we're going a little bit more into technical. We want to have it modular. We want it decoupled, and again, flexible. So LivePerson, few words about LivePerson client side, so we'll put the focus on what we're talking about. LivePerson client side really divides into two areas. Visitor scale, and we're talking about 1.8, and notice the small b, it's billion visits a month, around 150 billion requests a month. All of them are being processed by 150 machines. And they're not big machines, they're actually relatively regular machine or virtual machines. And that code runs in a hostile environment. Your customer's website, that's when our code runs. Go to, I don't know, customer.com, and our code has to run there and show. Now, I have anecdotal kind of stories where one customer decided that he doesn't like array indexes starting from 0. He likes it from 1. So he overrode the global array object. That 0 was used for technical information. But your code is there. So if you had a code which says 4 var I equals 0, and then you loop over an array, it would crash. This is the stupid example of hostility. Any and every permutation of browser modes, security features, cookie sets, and features in the browser happens out there. At the scale we're talking about, anything you can think of happens. So this is one problem space. Actually, we're not going to talk about it today because it's another presentation for a whole probably hour, even more. We're going to talk about customer scale, where we're talking around 10K customers. We dropped from B to K. So we're talking about 10K, 100K users, and it's a really friendly environment. You can do whatever you want, it's yours. It's your server, it's your code, you can use any library you want, you can use anything you want. This is more or less the focus of this presentation and the following ones. It's where the fun part happens. The visitor scale really trails because only very, very, very proven and stable technology can be moved up there. On the other hand, we have some legal limitations. You can't just use open source libraries and deploy them to the customer's websites. Maybe you can, out of 10,000 customers, you might be able to deploy to 9,900, but 100 customers will tell you, you know what? That open source license is not approved by our legal. So the only third-party library that is available for us, it's called Vanilla.js. So for people that don't know what it is, go to Vanilla.js. It's actually a joke. It's 0 byte size, supports in no browsers, and it's pure JavaScript. All our visitor scale JavaScript is written in Vanilla.js. It doesn't mean that we're not inspired by likes of jQuery, Backbone, and so on. We never copy. We are inspired by design patterns and technologies they use. Perfect example is animation. We needed to animate something in a visitor scale. We looked how jQuery does, and we actually realized that they really put a lot of thought into it. We rewrote the animation engine in around 20 lines of code, and that's the only thing we needed to deploy. Don't forget, jQuery is 29 kilobyte zipped, minified and zipped. It's a huge amount of size. So if your content is 1K that you're and then you need for animations 30K, something's wrong with the picture. Anyway, so this is about visitor scale a little bit. It's really, if you're interested in this, contact me after and we'll see how we can arrange and talk. We're going to concentrate about customer scale. It's a lot more fun, a lot more cutting edge. It's where all the single page applications and all the fun is happening, and you can really play and try and mix and match because it's only you. In the past, this was LivePerson. When I joined, this was LivePerson. Everything happens on the server. Everything. Templating, rendering, internationalization, logic, construction of JavaScript logic based on features and other things on the server. Everything happens there. The browser was a thin client, more or less, used to render the output. Anything you do has to go back to the server and re-render the whole page. That was about 7 years ago. Since then, we moved into the mode of working where the client is actually clever client. It contains the application itself, the UI logic. And when we started thinking about it, it actually contains a lot of business logic. The only non-business logic that the server keeps is how to do the data and the relationships between data. That's it. The rest, when a product defines a business logic, most of it is actually UI logic. I click on that, this happens. I click on that, this happens. That's UI logic. Business logic is when I submit a transaction, you need to verify the data, or you need to approve the transaction. That's business server-side logic. And security. This is the mode of development we're working now. We have a kind of clever client and relatively clever server, but each one does one thing what it was designed for. The server is very good managing data. The server is not that good playing with UI. The client is really good at playing with UI. That's its single purpose in life for browser, to draw a UI and to make it interactive. but it's not that good with all the security stuff. You can't protect purely on the client side. Just a small slide about what we did in the server side. As over the last few years, we went from coupled architecture, where one big blob does everything, to a decoupled architecture, where a lot of small boxes do the same and more. It's more or less kind of historically we're moving from Windows architecture to Linux, where Windows is, here is the OS, it does everything, and that's it, you're stuck. And here is a Linux architecture where it's like a toolbox. What do you need? After the kernel, what do you need? You have tools, you chain 3-4 tools, you got a product. You chain them in a different order, you get another functionality. And this is more or less the architecture we went to, and it works great. It improves stability, scalability, performance, security. How, like, why security? Because it's easier to protect a box that has one responsibility than to protect a box that does 100 things and nobody actually remembers what it does. So it also means faster release cycles, and you can develop on smaller teams. There is a decoupling between teams. Server side works perfectly, really. That's the picture. Went from one big box to a lot of small boxes. Different hardware, different networking even, different stacks, different everything. Now, we're going back to client side. We were here. Everybody probably knows this design pattern called spaghetti. You just write whatever you want, connect everything to what you can connect at this point, and make it work. Have a very, very late night, make it work, go home, sleep, come back a week later, you have no idea what's going on. You change something, everything else falls apart. So we went from spaghetti code to a lasagna code. This is probably a new design pattern. As per, there is food there, by the way, for people that get hungry. So it's more a layered approach. But hold on, we started on the server side, all coupled, one big blob, and then we ended up with different boxes. Why can't we apply it here? Why can't we make it like this? Everything's separate, everything is nice, everything is decoupled, everything is great. Why don't we cook little pieces of spaghetti in separate plates? It doesn't work like that. If you really start thinking to the end of this process, it goes, in the end of the day, all your code, all that you've written, goes into one browser. It goes into one window, and it actually runs on one thread. So, yes, you wrote your code in a very decoupled way. It's great. There's going to be a presentation why you really need to do it. You wrote it all. You decoupled software. Great. But it's a coupled deployment. So you went from a decoupled architecture to a coupled deployment. And this is one of the major differences between server-side development and client-side. Yes, you took a library from somebody. It's a great library. But when it runs, it eats CPU or leaks memory. That's it. It's not that that library will crash as in the previous, where one box would not just work and you can degrade. It can just eat memory and the browser will crash. There are lots of examples. Browsers have enough of memory leaks by themselves. So if we add that in libraries, it really adds a lot of complexity. That's why every time we add a library to our project, we really go through a relatively rigorous process of checking. Run that library for 24 hours. It says it, I don't know, a library that animates. Great. Take a div, run a script, leave it for the night, go home. Chances are you will come back and the browser will be dead. But do check it, especially when you're doing single-page applications. Now, in a little bit more organized manner, problems that arise from this lasagna design pattern. Code separation. How do we separate the code? How we stop writing one file that contains everything. Tooling. Tooling is really in its infancy for client-side development compared to any server-side development. Performance and resource management. and browser to server communications. Now, before I go, I'm going to talk about the elephant in this room, and that's called JavaScript, because JavaScript is weird, strange. Elon will say it's sad in his presentation. I actually hear flexible, powerful, and it's everywhere. And now, that's also JavaScript. I'm not joking, that's JavaScript. You can copy, paste this code, run it in the console, it will do alert 1. And probably since I'm on camera, I'm not supposed to say the website. It is a real website. You can go there, you can paste any code you like, and it will transfer it into this form. I don't exactly remember the number, but I think that it's around 1,000 characters here to do alert 1. It's not very efficient, but try to guess what it does. This is probably the best obfuscation technique. Now, JavaScript is, somebody said that it's very easy to write bad code. It's relatively harder to write good code. It takes a lot of discipline. Whereas in a server-side language like Java, the language itself forces you to certain design patterns. You have private, public methods. You have private, public variables. In JavaScript, there are none. Yes, you can code in the way that there are, and you should. And this talks about discipline. Yeah, I'll go and patch up some JavaScript. This is what I hear around this company. Yeah, it's just a little bit of JavaScript. Okay, take a computer, write it. Now make it production ready. Have you thought about it? Can I kill it? Yes. Normally it's yes, 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 and the time just extends. So it requires really a lot of JavaScript. As we said, tooling is in its infancy. It is really rapidly improving. For various reasons, Node.js, which is JavaScript server-side, came out. It really gave a big push. Tools to analyze your code and validate and play with it are really coming. This is exactly the attitude of server-side developers. It's the only language that developers think they can code without learning. I know Java. Yalla, I'll write JavaScript. If you will come with this attitude, you will fail. And I guarantee, you won't fail tomorrow, you won't fail maybe in a week, you will fail in a month. The code will explode in complexity. If you just take blindly server-side design patterns and apply them to JavaScript, you will fail. That's a fact. Learned from experience and from the reading on the web, but also from experience. Your library will become too complicated because the client side is not the server side. Nobody says that don't use it. Use, learn. There is 30 years or more of experience on the server side. Learn from them. Those guys probably were a lot clever, or some of them were a lot cleverer than all of us here. But learn from them, but take them all with a grain of salt. Take what you need, take the best part. You have the luxury of picking. And one last thing about JavaScript, it's here to stay. Like if anybody thinks that JavaScript will go away, let me ask you another question. Do you think the 4 companies, Google, Microsoft, Apple, and Mozilla, can actually sit at one table and agree on something? Let's change JavaScript. Okay, that means those 4 companies have to sit and agree on one language. The only reason we have JavaScript is because it became it entered the world through a back door. I have a weekend. I need something to make this page a little bit more dynamic. That's how JavaScript was born. Now, Microsoft comes and says, yeah, I like this JavaScript I need to do, but let's code JScript. Let's make it just a little bit more interesting for everybody. Let's make it just a bit different. And by the way, we have our browser, which is another talk, which is never mind. Yes, so JavaScript is here to stay. If you don't take it as a fact, nobody says forever, but for the next, 5, 10 years, if you don't know JavaScript, something's missing. I see this happening in this company, people that we have very, very strong server-side developers, and some of them actually come and say, tell me, there is this JavaScript, I need to learn it a bit. Tell me what to read. Spend some time with me, play with me. Like play with code, show me some things. Let me just understand. That means those people really are thinking about their tool set and their experience. All the rest, like, we're still, Node.js is still young, but it's a force that is coming. It's the young guy that can come and do the same that JavaScript did to the web. Maybe not, it's arguable, where and what, but be aware. The best defense is knowledge, as always. Let's talk back about code separation. Separate your code. Elon will talk a little bit more, so I'll skip about this. But don't be afraid of files. One file, one job. Learn from Java. One file, one class. That's it. Don't be afraid. Use required.js and common.js for management and separation and building. MV Star Provider. If you are doing anything except a simple web page or simple website, if you're doing a single page application, do not think you can write it in jQuery. You can, you will fail in about 3 to 6 months. You will come back and have no idea what is going on. As the complexity goes exponentially up, you will have no idea you'll get to a point where you can't do a change because of the risk that it will affect something and you don't know what. A revealing pattern, please use. We had, just to give you our own experience, we run something called WebTech Forum internally in the company for all client-side developers. We had a long discussion about should we or should we not use the revealing pattern. Revealing pattern for server-side people, it actually allows you to write private and public methods and variables. It will affect debugging, how do I debug, how I do this, how I do that. I think it's kind of, it almost came to the point we don't know, let's argue a bit more. It took kind of, yes, we're using it. We've been using it for the last 9 months. Do use it. Like, learn from that experience, if nothing else. Use it. It looks weird, it looks tough, it actually improves your design. No more you can just say, oh, I'll just hack. I'll connect that object to that object because it's public and it will work. Yes, you saved 5 minutes now, you did the job in 5 minutes. 1 month later, probably you, maybe not, will spend a week trying to understand why something which is disconnected broke something else in the code. Reusable components. This is some kind of another design pattern. Package and package and package and package. Write the simplest collection of utilities, package them. You want to reuse a UI element, package it. You want to have an API, package it. Package as much as possible, as many as possible black boxes. It's much easier to construct a new application. You just reuse the same black boxes. If you notice, if any of you worked with freelancers, the good ones come with a tool set in any language. If you take a PHP freelancer, a good one, he comes and says, I have around 50 classes and 100 utilities that are packaged in little boxes. They're like client-side APIs. And I'm going to use them. The more you abstract, the more reusable your code becomes. Unit tests, I'm really not going to discuss here. I'm just going to ask one question. When you write a server-side language, do you even ask if you need a unit test? For most of the companies, you don't. It's a fact. JavaScript is no different. If you think how much complexity there is, write unit tests, it also improves your design patterns. We had cases, a lot of them, when a person writes code, can't unit test it, changes the code, and actually says, wow, it made my code a lot cleaner. We can talk a lot about unit tests, but automation tests across all browsers, if you have the budget, do it. Like, I can't tell a startup do it, But if you're not called a startup, do it in whatever way. There are companies, services, mobile, not mobile, they all allow you to do that. There are even JavaScript frameworks that allow you to automate. Do it because you can't test all the browsers. The browsers are going to kill you out there. You don't want to come out and realize that in IE8 in a certain mode, the application doesn't even start up. Tooling. The second part of the title, it's actually very LivePerson specific. I don't know how you connect. Use correct tool for the job. A lot of server-side guys, when they needed to concatenate files in LivePerson, they just wrote a Maven plugin, which took them about 2 weeks to do, and still didn't solve all the problems, because it's not designed to do that. Use build tools. Use Grunt, use Yeoman, use something. The installation takes about 2 hours from scratch. If you don't know even what Grunt is, the installation takes 2 hours, and it comes out with thousands of plugins that do everything just by adding a one configuration line. Concatenate all my files, one line. Compress, minify all my files, one line. That's it. You do compile your projects in Java. This is more or less kind of a compilation. You don't need to do that in dev. It's not like you make a choice, build, check. You set it up during dev without the build. When you pass it to QA, build it.
Grunt like R?
R just concatenates files of require. Grunt is above R, and it can do a lot of tasks. It's like, R is like Ant, although this is like, don't say I said that, but Grunt is like Maven if we do comparison to Java. Very, very loose comparisons. They're designed for client-side, they really worked, and this is a way for you to bring Node.js into the company. That's the one way that is very easy to bring. Use code analysis tools. Again, one of the examples. We had a problem in our project. People develop their code, they don't minify it. They actually don't put semicolons everywhere you need it. And then when you concatenate the files, sometimes it works, and sometimes it just crashes, because if you forget a semicolon in a wrong place, and the code after it is also, by chance, a bit wrong, it becomes illegal, the compiler gets confused. Don't. JS, we put JS hint, and it basically breaks the build and tells you there is a missing semicolon at line 15 in that file. Go, put it, continue. Use code complexity tools. This is something relatively new. This is an example screenshot on our project, for example. There is a lot of information I just took just to try to impress you with a big graph with a lot of numbers. But the advice is it's very easy. It's a Node.js plugin that you give it a folder, and it constructs all of this UI, and this is like 1/10 of what it gives of graphs. It uses some algorithm to compute complexity of each file. And complexity apparently has direct relationship to the number of errors, or probability of errors in this file. So we have one file which has 1,500 lines of code. We know about this file. We know it's one of the historical APIs we've done. So we are kind of okay with it. But you see the difference. Most of the files are very, very small. And it really shows, I ran this a couple of times, and it really shows historically what happens with your code. And you see people suddenly committing a code, and one of the maintainability graphs drops down. And then you just come and actually you realize there is a problem. They should have split that into two files. This is one of the tools to actually kind of monitor the health of your system by automatic tools. It's called Plata. Just you get a lot of philosophical pictures and links. So search for Plata.js or search for Plata on GitHub. So you can do this. Tooling. Oops, we jumped again. Okay. One last thing on tooling, monitor. I think Google says if you can't measure it, it doesn't exist. If you're saying my site is very, very fast, what is very, very fast? And what's the difference between very fast and very, very fast? Monitor. There are tons. You can be as cheap or as expensive. Really, there are tons of tools. Just put it in. Monitor from inside, monitor in dev, monitor out from outside, monitor. This is like a preaching section. How many people know what RAM stands for? It stands for Real User Monitoring, where there are services that actually use real users to provide you reports. We had cases where when your visitors are so spread out, when one ISP in Canada had a problem, and that's the only way to find out. A relatively small percentage of all your users has a very crappy experience. Do you care? You probably do, because those visitors bring you money. How can you find out? Not really, unless you use something like real user monitoring. Again, there are services. It depends on your business. Sometimes you can use your own. We did something as a POC using our own visitors, and it does give surprising numbers, even about our own website. We realized that sometimes it takes 45 seconds for the website page to complete. Just like, why? Okay, they found it. There was a little bit misunderstanding in the way the page was structured. You will find surprising results. Coming back to all this coupled deployment, memory. It's Chrome DevTools is really the tool you should use. If you have a memory leak in IE, you swear, you make a couple of cups of coffee, and you have a late night. It's very, very tough to find a memory leak in IE or identify what causes it. It's almost down to the level of Visual Basic Programming or basic programming with log lines and checking. Run your code for at least 24 hours. Just to give you an example, IE8 leaks 4 kilobytes of memory for every JSON-P request. I'll give you another example. We use JSON-P I wrote the library about 6 years ago, and it's really doing all those billions of connections. The thing is, we never found it. Why? Because a person stays on a page for what, 30 minutes? So you leak 30 minutes divided by how many requests a minute you do times 4K. That's how much you leak. So you leak, the page refreshes, the memory comes back. For a single page application that does a request every 2 seconds, and we have one like that, 24 hours later, the browser crashes. Actually, it crashes 8 hours later. But 4K, really, IE8, fun. We support it, it crashes. Nothing else leaks, just IE8. DOM elements, this is kind of a given. Render only what you see. Don't just render. The best example is grids. You don't know if you're going to get 10 lines or 100. Render 20 or 10, however the viewport the visitor sees. Don't render it all. It's really tough for the browser to manage a big DOM tree and clean up after yourself. It's like, please, I had enough with those libraries where they work great, but they leave so much garbage afterwards that sometimes we write wrappers that say, here is the library, after we stop using it, we know what to clean up. Just because the value it gives is easier to clean up than to redevelop. One of the kind of 1, 2, 3s that anywhere you talk about performance is number of requests. Concatenate your files using a build tool. Don't be scared of the number of files. Optimize images, use sprites. And one other thing, which is not so obvious, number of API requests. Your single page application probably is not talking to one API. Probably talks to tons. At least in our case, we talk sometimes to 5, 6 APIs. All ours. If you issue 6 requests and you are supporting all the browsers, again, the favorite browser of every client-side developer called IE, it will block. It will make them waterfall. Even though if you issue 6, 8 calls at the same time, it will waterfall them. In addition to all the images you are downloading, because it's probably the same domain for now. There is not much you can do except go back to your server-side guys and make them work and tell them, put a proxy on all my APIs and define a way for me to, in one request, to query multiple APIs. This is not new. This is what Google does and others. There is no other way to improve performance. Put a proxy in your farm. It's a lot faster. It's a lot more reliable. It doesn't work for mixed operations, like I want to get that and delete that. That's a little bit tricky. Normally it works for only gets. Give me a list of countries, give me a list of users, give me something else, one request, and it will give it all in one response. Just kind of ad hoc ideas, optimize your images. Again, in the build tools, you have tools. You just configure it. You don't have to write anything. You can bring the size down by about 30% just by running over your PNGs and JPEGs and GIFs. The browser can't render it all. So it just removes all unnecessary information. Compress all output. It shouldn't even be a question. It shouldn't be even like, please production compress it. It's cheap in Apache. It's almost like just add mod deflate and configure it, copy paste some configuration and comment some lines. If you have a very, very high traffic site, compressing in real time might be too expensive. You can pre-compress everything up front and create a file called a.js and a.js.gzip, and then in Apache write a mod rewrite rule which looks at the headers, and if the browser supports gzip, it will actually return the gzip file with correct headers. This is normally you should do it because it's a little bit trickier. Normally you should do it only for the really, really high traffic sites. I have a lot more to talk about, but enough probably from me. Ilan Hami, who is a developer in the framework team, will talk about MVC and how to stay sane and happy while writing a single page application. We are hiring. If you got interested, write an email to me or to this long email address. Thank you. If you have